The A320 was the first commercial airliner to utilize a digital fly-by-wire flight control system. All flight control surfaces are electrically controlled and hydraulically actuated. This eliminates most of the traditional mechanical complexity and results in reduced weight, reduced maintenance costs, and increased reliability. It also provides optimum aircraft performance and improved fuel efficiency. Control surfaces on the A320 are conventional. Pitch control is achieved by two elevators mounted on a trimmable horizontal stabilizer. There are 5 spoiler panels and 1 aileron on each wing. Roll control is achieved by the ailerons and spoilers 2, 3, 4, and 5. In-flight speed brakes are provided by spoilers 2, 3, and 4, and ground spoilers are provided by all 5 spoiler panels on each wing. Yaw control is achieved by a one-piece rudder mounted on the vertical stabilizer. The trimmable horizontal stabilizer, or THS, and the rudder, in addition to electrical control, are mechanically linked to cockpit controls to provide a means of controlling the aircraft should a temporary complete loss of electrical power occur. Each wing has 2 trailing edge flap surfaces and 5 leading edge slat surfaces that act as lift augmentation devices for takeoff and landing. The pitch trim wheels, flaps lever, speed brake lever, and rudder trim switch are located on the center pedestal. 2 sets of rudder pedals are located at each pilot station. Note, there is no aileron trim. Touch control location to see an enlargement, or the right arrow to continue. The flaps and slats position indicator is found on the upper ECAM display unit. Additional flight control information is found in the memo section. The traditional control column has been replaced by a side stick controller. The side stick, along with an auto trim system, enables the pilot to fly the aircraft more smoothly and with more precision and less effort, and provides a more comfortable ride for the passengers. Inputs from the side stick or from the autopilot are processed by the flight control computers, which command the control surface actuators to move as necessary. This system enhances flight safety by providing complete protection against flight outside the normal flight envelope and protects against stall, wind shear, overstress, and overspeed. The side stick controllers are located on the side consoles. Flight control is achieved by 3 types of computers arranged to provide redundancy and failure protection. Different manufacturers, different hardware, and different software have been used to eliminate the potential for common errors. Electrical power sources are also from different electrical buses. There are 2 elevator aileron computers, or ELACs, for elevator, stabilizer, and aileron control. 3 spoiler elevator computers, or SECs, for normal spoilers control and standby elevator and stabilizer control. 2 flight augmentation computers, or FACs, for electrical rudder control. 1 SEC, or 1 ELAC, is capable of controlling the aircraft in both the roll and pitch axis. The electronic flight control switches are located on the left and right sides of the overhead panel. The ECAM flight control page is displayed automatically with certain flight control faults and can be selected at any time with the flight control push-button switch on the ECAM control panel. The ECAM wheel page also duplicates the ground spoiler status. two side sticks allow the pilots to control the aircraft manually in both pitch and roll. They are not linked mechanically, but simultaneous inputs by the captain and first officer are summed. The sum is limited to the maximum deflection by a single side stick. It is very important, therefore, for both pilots to be clear about who has control of the aircraft. There is no direct feedback or artificial feel system except for a simple spring centering device which neutralizes the side stick when it is released. On the ground, after the first engine is running, the side stick position indicators come into view on the PFD. They disappear when the aircraft is airborne. The white corner indices indicate the limit of side stick travel, while the white cross indicates the actual side stick order from both side sticks. This is useful for checking full side stick movement before takeoff, but does not indicate actual control surface position. For control checks, use the surface position indicators on the ECAM flight control page. The side stick has two switches, a dual-function autopilot disconnect priority takeover push button, and a communications push-to-talk switch. Whenever the autopilot is engaged, a solenoid-operated detent locks the side stick in the neutral position. If necessary, the detent can be overridden with sufficient pressure to unlock the side stick, which will also disconnect the autopilot. The normal method to disconnect the autopilot, however, is to press the autopilot disconnect push button on the side stick. A pilot can take full control and deactivate the other side stick by pressing and holding his priority takeover push button. If held for at least 40 seconds, the other side stick is latched out and the priority takeover push button can be released without losing priority. Each time a side stick priority is taken, an audio message, priority left or priority right, is heard. Touch a priority takeover push button.
Priority right.
In addition, the side stick priority lights on the glare shield indicate which pilot has control. A red arrow in front of a pilot indicates his side stick has been deactivated and the other pilot has control. To reactivate a side stick, momentarily press its priority takeover push button. The last pilot to press and hold the priority takeover push button gets control.
Priority left. Priority right. Priority left. Priority right.
Note the first officer's side stick is not in the neutral position. Then touch the captain's side stick priority takeover push button to take control.
Priority left.
A green light, either captain or first officer, is displayed in front of the pilot who has control when the deactivated side stick is not in the neutral position. If the deactivated side stick is released to neutral, the green light goes out, but the red arrow remains. Touch the first officer's side stick to release it to neutral. For pitch control, the aircraft is equipped with two elevators. Each elevator has two hydraulic actuators powered by different hydraulic systems and controlled by its associated ELAC. Normally, ELAC 2 controls the elevators. If ELAC 2 or any of its associated hydraulic systems or components fail, control automatically shifts to ELAC 1 and its associated hydraulic systems and components. If both ELAC 1 and 2 fail, control automatically shifts to SEC 2 or SEC 1 depending on the nature of the failure. The elevator position and hydraulic pressure indication is displayed on the ECAM flight control page. The hydraulic pressure indicator changes to amber when the associated actuator is not available due to hydraulic failure or jamming. The position indicator changes to amber when both actuators are unavailable. An amber partial box is displayed if the associated computer fails. For pitch trim, the aircraft is equipped with a trimmable horizontal stabilizer or THS. The THS is driven by two hydraulic motors, one powered by the green hydraulic system, the other by the yellow hydraulic system. For the auto pitch trim system, the hydraulic motors are driven by one of three electric motors with the other two in standby. Normally, ELAC 2 controls motor number 1. If ELAC 2 or any of its associated hydraulic systems or components fail, control automatically shifts to ELAC 1 and its associated hydraulic systems and components. If both ELAC 1 and 2 fail, control automatically shifts to SEC 2 or SEC 1, depending on the nature of the failure. The trimmable horizontal stabilizer is mechanically linked to the pitch control wheel in the cockpit. Moving or holding the pitch trim wheel always has priority over electrical control and is available if either the green or yellow hydraulic system is available. With the failure of either the green or yellow hydraulic system, the trimmable horizontal stabilizer will operate at half speed with no adverse effects. The trimmable horizontal stabilizer position is indicated on a scale next to the pitch trim wheel located on the center pedestal. The scale is painted green to indicate the normal takeoff range of 2.5 degrees nose down to 2.5 degrees nose up. The current setting is also displayed on the ECAM flight control page along with the hydraulic pressure indication, which changes to amber if hydraulic system pressure is low. The legend pitch trim changes to amber if the stabilizer is jammed. One aileron and 4 flight spoilers on each wing provide roll control. Each aileron, as with the elevators, has 2 hydraulic actuators, each powered by a different hydraulic system and controlled by its associated ELAC. Normally, ELAC 1 and its associated actuators operates in active mode, while ELAC 2 and its associated actuators are in standby mode, ready to take over in the event of a failure. Touch the ELAC 1 fail button or the right arrow to continue. Each spoiler panel is positioned by a single servo jack and is powered by a combination of one of the 3 hydraulic systems and one of the 3 SECs. If a SEC fails, control to its associated spoiler panel is lost and the spoilers are automatically retracted and hydraulically held down. If a hydraulic system failure occurs while a spoiler panel is extended, it will be blown down by aerodynamic forces. Aileron and spoiler position indications are displayed on the ECAM flight control page. Spoiler indications are also repeated on the ECAM wheel page. A green arrow is displayed as soon as the spoiler panel is raised out of its retracted position. The hydraulic pressure indication turns amber if the hydraulic pressure is low or an actuator has jammed. An amber partial box is displayed if the associated computer fails or if the associated ELAC or SEC push-button switch is selected off. Yaw control is provided by a single rudder panel driven by 3 independent hydraulic jacks operating in parallel. ELAC 1 computes yaw damping and turn coordination orders from the side stick, autopilot, or rudder pedals, and transmits these orders to FAC 1.
FAC1 controls an actuator powered by the green hydraulic system, which in turn drives all 3 rudder hydraulic jacks. FAC2, along with a yellow actuator, operates in the standby mode, ready to take over in case of a failure. There is no feedback to the rudder pedals from the yaw damping and turn coordination functions.
The 2 sets of rudder pedals are mechanically linked to each other and to the rudder itself, and are available in manual flight for takeoff, landing, and engine-out flight. Rudder and rudder pedal deflection is limited by the FACs as a function of aircraft speed to prevent overstressing of the airframe at high speeds.
Rudder trim is provided by 2 motors, one driven by FAC1, the other by FAC2. Normally, motor 1 is active, with motor 2 in standby. In manual flight with the autopilot off, rudder trim is applied with the rudder trim switch located on the pedestal, and is normally only used when an engine failure occurs. Using rudder trim causes displacement of the rudder pedals. A reset button allows the trim to be reset to 0. Note, with the autopilot engaged, the rudder trim rotary switch and rudder trim reset push button are not active. Rudder position is displayed on the ECAM flight control page. The hydraulic indicator changes to amber with a hydraulic system failure. The rudder symbol and scale become amber if all 3 hydraulic systems pressures are low. The rudder trim position, normally blue, changes to amber if the rudder trim reset fails. The rudder travel limiter high-speed limits are displayed.
Spoiler panels 2, 3, and 4 act as speed brakes in flight. However, the roll control function of the spoiler panels always has priority, and speed brakes may retract to satisfy a roll order. Spoiler panel 2 max deflection is half that of spoiler panels 3 and 4. Speed brakes are selected by pushing down and then moving the speed brake lever aft to the desired position. There is a detent at the half position. The speed brakes will not extend if the flaps are in config full, and if extended, will retract when config full is selected. Touch the speed brake lever to see the operation of the speed brakes.
The speed brakes are also inhibited if Sect1 and Sect3 both have faults, or angle of attack protection is active. If an elevator has a fault, spoilers 3 and 4 will be inhibited.
When the aircraft is flying faster than 315 knots, or Mach 0.75, and the autopilot is engaged, the speed brake retraction rate is reduced. It takes from about 25 seconds to 50 seconds for the speed brakes to retract, depending on aircraft modifications. On some aircraft, again depending on aircraft modification, when the autopilot is engaged, max speed brake panel deflection is reduced and is achieved with half speed brake lever selection. Speed brake position is displayed on the ECAM flight control page and is duplicated on the ECAM wheel page. The message speed brake appears in the memo section of the upper ECAM when the speed brakes are extended. It flashes amber when engine N1 is greater than 50%. All 5 spoiler panels act as ground spoilers. They are armed for takeoff and landing by raising the speed brake lever straight up into the armed position. The message ground spoilers armed appears on the upper ECAM. The ground spoilers, when armed, extend automatically during a rejected takeoff when the aircraft speed is greater than 72 knots and both thrust levers are reduced to idle. On landing, the ground spoilers extend when both main landing gear touch down and the thrust levers are set to idle. If the ground spoilers were not armed for landing, they will extend automatically after both main gear have touched down when at least one engine is selected to reverse and the other is at idle. On some aircraft, depending on modification, the ground spoilers will partially extend when reverse is selected on at least one engine and only one main landing gear strut is compressed. For example, in a crosswind landing, if the upwind gear touches down first and reverse is selected, the ground spoilers will partially extend to ease the other landing gear onto the runway. Consequently, full ground spoiler extension will occur. The ground spoilers will retract automatically during a touch-and-go landing when at least one thrust lever is advanced above 20 degrees. Touch the thrust levers to select takeoff power. When the ground spoilers extend, the speed brake lever does not move. The only visual indication that they have extended is on the lower ECAM wheel page, which was automatically displayed for landing or in the event of a rejected takeoff. Each wing has 5 leading edge slat surfaces and 2 trailing edge flap surfaces. Slats and flaps are selected by a single flaps lever located on the center pedestal. Touch the flaps lever to select full flaps. Two dual-channel slat flap control computers, or SFCCs, monitor and control the slats and flaps. When a flap selection is made with the flaps lever, a signal is sent to the SFCCs, which in turn control the slats and flaps power control units, or PCUs. Each SFCC controls and monitors one motor of the flap PCU and one motor of the slat PCU. These hydraulic motors, through a mechanical system of shafts, gearboxes, and actuators, move the slats and flaps to the desired position. When the slats and flaps have reached their selected position, pressure off brakes, or POBs, lock the hydraulic motors to prevent unwanted movement. With the failure of one of the associated hydraulic systems, or one of the SFCCs, the corresponding slats and/or flaps will operate at half speed.
The SFCCs continuously monitor asymmetry position pickoff units, or APPUs, and feedback position pickoff units, or FPPUs, which measure slat and flap position for asymmetry, runaway, uncommanded movement, and other failure conditions. If both SFCCs detect a failure, the wingtip brakes, or WTBs, lock the slats, or flaps position, and send a warning to the ECAM. Wingtip brakes, once activated, can only be reset on the ground.
Two indication position pickoff units, or IPPUs, one for the slats and one for the flaps, send position data to the upper ECAM slats flaps position indicator. There is an interconnecting strut with flap attachment failure detection sensors between the inboard and outboard flaps. If a position difference is sensed, a signal is sent to one of the landing gear control interface units, or LGCIUs, and the movement of the flaps is stopped by the pressure on brakes. The flaps lever has 5 detents, 0, 1, 2, 3, and full, corresponding to the different slat flap configurations. Below the flap lever knob is a collar, which must be lifted in order to move the lever out of each detent. There is an internal balk between positions 1 and 2, and between positions 3 and full. To move past a balk, the collar must be released, then squeezed again, preventing an excessive one-movement selection from full in the event of a go-around, and from 2 to 0 during normal retraction. The flap indicator on the upper E-cam uses the shape of the wing to display slat flap configuration. A gray symbol represents the fixed wing center section, and the slats and flaps are represented by green triangles on either end of the wing. With the first flap selection, white dots and an S and F appear to show the possible slat flap configurations. The legend flap and the selected flap lever position is displayed in cyan, and small cyan triangles move out to the selected position. When the slats flaps reach their new position, the flap legend changes from cyan to white. The selected flaps lever position changes from cyan to green, and the cyan triangles are replaced with green position indicators. The chart shows the possible slat flap configurations. When config 1 is selected for takeoff on the ground, both slats and flaps extend. When config 1 is selected in flight, only the slats extend, and the flaps will then extend when the lever is selected to the config 2 position. After takeoff with config 1 plus F, the flaps only will automatically retract at 210 knots to prevent exceeding the max flap extension speed of 215 knots. This may occur at high aircraft gross weights where the slat retraction speed is close to 210 knots. After an automatic retraction, automatic re-extension does not occur if the speed again drops below 210 knots. When the flaps are extended, the ailerons droop 5 degrees. This position is indicated on the E-cam by an index on the aileron scale. If both associated hydraulic systems are inoperative, or there is a fault in the slats or flaps, the flap legend and the position indicators change to amber. The slats locked message or the flaps locked message is displayed along with an E-cam caution when the wingtip brakes are engaged or when there is an asymmetry condition between the slats or flaps. An alpha speed lock function prevents slat retraction at high angles of attack and low speeds to guard against stall. If angle of attack exceeds 8.6 degrees or the airspeed is less than 148 knots, slat retraction from position 1 to 0 is inhibited. When the flaps lever is moved from 1 to 0 under these conditions, the flaps only will retract. The slats will eventually retract when the speed increases to VLS for config 0. Note, slats do not automatically extend if pitch attitude is exceeded or if airspeed falls below 148 knots. All aircraft fitted with fly-by-wire control systems have within the flight control computers control laws which determine how the aircraft flight control surfaces should be positioned at any given time. On the A320, normal law is active when all flight control surfaces function, even after certain flight control computer, hydraulic, or electrical faults. Protections are provided in flight, including load factor limitation, pitch attitude protection, angle of attack protection, high speed protection, bank angle protection, low energy warning, and load alleviation protection. Normal law encompasses 3 modes: ground mode, flight mode, and flare mode. On the ground, because sophisticated protections are not required, elevator deflection is in direct proportion to side stick movement. Auto trim is not functional, allowing the pilots to set the trimmable horizontal stabilizer manually for takeoff to adjust for C of G variations. Ground mode allows the elevators to move to the max deflection of 30 degrees nose up and 15 degrees nose down in order to perform the pre-flight control check. Upon reaching 70 knots during the takeoff roll, max nose up elevator deflection is reduced to 20 degrees to prevent the possibility of a tail strike at rotation. As soon as the aircraft becomes airborne, the transition to flight mode is blended in over a period of 5 seconds. In pitch normal law, movement of the side stick either fore or aft results in a load factor demand or constant G maneuver rather than a directly proportional elevator displacement. With the side stick in the neutral position, the pitch demand is always to maintain a constant 1G. If the aircraft is disturbed due to atmospheric influences, for example, it will always attempt to return to its original pitch attitude and 1G. A conventional aircraft, once disturbed, would continue to diverge from its original flight path, at least in the short term. Moving the side stick aft results in a demand greater than 1G or positive G, and moving it forward results in a demand for less than 1G or negative G. Once the aircraft is established in the desired attitude, the side stick can be released to its neutral position, and the aircraft will continue to maintain the new attitude and 1G. Control inputs are made to alter or change the flight path, not to maintain it. Therefore, a side stick input can be considered as a selected vector through space. In normal law, pitch trim is automatic. With prolonged side stick input, the trimmable horizontal stabilizer is automatically trimmed to bring elevator deflection back to zero. Also, with the side stick in neutral, power, speed, or configuration changes are automatically trimmed out to maintain a constant 1G. The aircraft will decelerate or accelerate in level flight with no pilot input, all the while maintaining 1G. Without auto trim, the aircraft would pitch up or down just as it does in a conventional aircraft. In a turn of up to 33 degrees of bank, the pilot does not have to hold back pressure on the side stick to maintain altitude. Once the turn is established, the side stick can be released to neutral. As the aircraft descends through 50 feet for landing, flight mode changes to flare mode, a modified form of pitch normal law. The aircraft memorizes the pitch attitude at 50 feet, then at 30 feet, begins to progressively reduce the pitch attitude to -2 degrees over a period of 8 seconds. The auto trim is also deactivated. This simulates the behavior of a conventional aircraft as it becomes influenced by ground effect and means that the pilot must apply a conventional flare technique, moving the side stick aft to achieve the correct landing attitude for touchdown. If a go-around is attempted below 50 feet, flight mode and therefore auto trim would not be restored until reaching 50 feet, and more than normal pitch force may be required to pull the aircraft up to and maintain the go-around attitude. Upon touchdown, elevator deflection is again restored to a direct elevator-side stick relationship. 5 seconds after touchdown, the trimmable horizontal stabilizer is automatically reset to 0 degrees. In pitch normal law, side stick inputs are filtered through a limiter, which will restrict the nose up or nose down demands to maintain the aircraft within its structural design limits at all times. The load factor is limited to plus 2.5 Gs to minus 1 G with the flaps retracted. With the flaps extended, load factor is limited to plus 2 Gs to 0 G. Load factor is momentarily displayed on the lower E-cam whenever the G load is above 1.4 Gs or below 0.7 G. Pitch attitude is limited to a maximum of 30 degrees nose up in config 0 to 3, progressively reduced to 25 degrees at low speed, and with the flaps in the full position is limited to 25 degrees nose up, progressively reduced to 20 degrees at low speed. Nose down pitch attitude is limited to minus 15 degrees. These limits were chosen to avoid entering the angle of attack and high-speed protection envelopes, which will be covered later. If flying at the nose-up limitation, pulling back further on the side stick has no effect. However, full nose-down demands are still available. At the nose-down limitation, the reverse is true. Pushing further on the side stick would have no effect, but full nose-up authority is available. Pitch attitude limits are displayed on the PFD as small green horizontal bars. As well, a large red arrow pointing downward is displayed at the nose-up limit. The flight director bars disappear from the PFD when pitch attitude exceeds 25 degrees nose up or 13 degrees nose down. At the low end of the speed scale, an aircraft may reach an angle of attack at which max lift is attained. This is defined as max coefficient of lift, or alpha CL max. At higher angles of attack, lift is reduced and the aircraft will eventually stall. Conventional aircraft utilize systems such as stick shakers or stick pushers to give pilots warning of an impending stall.
When the A320 reaches an angle of attack defined as alpha protection or alpha prot, the side stick controller, rather than demanding a load factor, switches to a protection mode in which it directly demands angle of attack. At an angle of attack of alpha prot plus 1 degree, the autopilot will disengage.
The second level of protection is that, at alpha floor, a speed slightly lower than alpha prot, toga thrust is automatically applied, regardless of thrust lever position or whether the auto thrust is engaged. Alpha floor is enunciated on the FMA. The third level of protection is that the angle of attack will not be allowed to exceed alpha max, even if the pilot pulls the side stick all the way back. It is safe, therefore, if required for wind shear or terrain clearance maneuvers, to rapidly pull the side stick fully back, even at low speeds. The load factor limitation still applies. If the side stick is released, the angle of attack returns to alpha prot and stays there. Alpha prot, alpha floor, and alpha max are computed by the flight augmentation computers or FACs and vary depending on aircraft weight, configuration, and C of G. To exit alpha protection, the side stick must be pushed forward. When the aircraft exits alpha floor conditions, alpha floor will be replaced by the message toga lock on the FMA. To cancel toga lock, the auto thrust must be disconnected by pressing the auto thrust disconnect push button or the auto thrust push button on the FCU panel. Then, bring the thrust levers back into the auto thrust operating range and rearm the auto thrust by pressing the auto thrust push button on the FCU panel. On the PFD speed scale, alpha prot is represented by the top end of the black and amber strip, while alpha max is represented by the top of the red strip. VLS is the lowest selectable speed, which can be selected by the pilot with the speed select knob on the FCU and represents 1.28 times Vstall in the clean configuration. It provides a buffer against reaching alpha prot. With auto thrust engaged, the speed will not normally be allowed to fall below VLS. Angle of attack protection is also available at high altitude and high speed, where it gives protection at the buffet boundary. At altitudes higher than optimum, for a given weight, the spread between alpha prot and actual aircraft speed can be quite small.
The high-speed protection system will not allow the aircraft to exceed its design limit speed of 383 knots, Mach 0.89. At VMO, max operating speed in level flight plus 6 knots, or MMO plus 0.01, the autopilot disconnects, and a nose-up load factor demand is introduced to allow the aircraft to return to the normal speed envelope. VMO, MMO is indicated on the PFD speed scale by a red and black strip, and the high-speed protection symbol is indicated by a pair of green horizontal bars.
If the pilot gently applies full forward side stick input and holds it there, the speed will stabilize at a maximum of VMO plus 16 knots, or MMO to MMO plus 0.04. If he suddenly applies full forward side stick and holds it there, the speed may momentarily increase to a limit of VMO plus 30 knots, then will stabilize at VMO plus 16 knots. If the stick is released to neutral, the speed will stabilize at VMO or MMO. When high-speed protection is active, the autopilot disconnects, and the horizontal stabilizer stops auto-trimming, with only elevator used to bring the aircraft back to within the normal speed envelope. When the aircraft enters the high-speed protection area, an overspeed warning is generated to ECAM, the continuous repetitive chime is heard, and the master warning flashes. The autopilot off warning is also displayed if the autopilot was on. Between 2,000 feet and 100 feet, with flaps in config 2, 3, or full, the low-energy warning is triggered if the aircraft speed drops below a threshold where power must be increased to maintain the flight profile. The oral warning, speed, 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 is repeated every 5 seconds. Moving the thrust levers forward of the climb detent up to the MCT detent will allow the thrust to increase in order to recover small decreases in speed. This action deactivates the auto thrust, although it remains armed, and gives an immediate burst of power. Once the speed is recovered, bringing the thrust levers back to the climb detent will reactivate the auto thrust. If necessary, move the thrust levers to the toga position to initiate a go-around. In lateral ground mode, as with pitch ground mode, the side stick demands aileron and spoiler deflection directly proportional to side stick inputs. Up to 70 knots, full aileron spoiler deflection is available in order to perform the pre-takeoff control check. Above 80 knots, only half roll authority is available to prevent over-controlling and to allow a smooth transition from ground to flight mode. During a rejected takeoff or on landing, full aileron authority is restored when the ground spoilers extend. The transition from ground to flight mode occurs 1/2 second after the aircraft becomes airborne. In flight, the side stick demands a roll rate rather than a direct aileron spoiler deflection. The rate of roll is proportional to the amount of lateral side stick input, with a maximum rate of 15 degrees per second if held to the stop. The lateral normal law is combined roll and yaw law. Thus, a side stick input mixes orders to the ailerons, spoilers, and yaw damper. The side stick also gives a bank angle demand when it is released to neutral. Stick neutral is a demand for zero roll rate. Thus, in a bank of up to 33 degrees, the aircraft will maintain the bank angle at the time the stick was released. Also, feedback to the pitch normal law is made, such that up to 33 degrees of bank, an increased G demand is made to compensate for the bank angle, and no additional back pressure is necessary on the side stick while in the turn. If the rudder pedals are depressed when the side stick is in the neutral position, the lateral controls attempt to zero the roll rate, and a side slip is automatically performed. The aircraft trajectory does not change significantly. This is an important technique for crosswind landings. In the engine failure case, if the side stick is left in neutral, the aircraft attempts to zero the induced roll rate by automatically displacing the ailerons, spoilers, and rudder. However, a slow heading drift will occur as the aircraft rolls and yaws in response to the engine failure, and pilot action on the rudder pedals is required to stop the heading drift and bring the aircraft back to the ideal state of side slip. That is, wings level, ailerons and spoilers neutral, with rudder displacement only. To assist the pilot, a side slip target indicator is available on the PFD. The color changes from yellow to blue, with flaps at 1, 2, or 3. Pilot response is instinctive, as with a conventional slip ball, step on the target to align it with the roll index. The maximum bank angle that can be achieved is 67 degrees. Full lateral side stick must be applied and held. If the side stick is released, the aircraft will return to and maintain 33 degrees of bank. Beyond 33 degrees of bank, there is no pitch compensation. Aft control inputs would be required, as in a conventional aircraft, to maintain the desired pitch angle. The max bank angle of 67 degrees is indicated on the PFD by a pair of green bars. When the bank angle exceeds 45 degrees, the flight director bars disappear. The bank angle limitation of 67 degrees corresponds to the design G factor limitation of 2.5 Gs. With flaps extended, the bank angle is limited to 60 degrees in level flight to correspond with the design factor limitation with flaps extended of 2 Gs. When high speed or angle of attack protection is active, the maximum angle of bank is limited to 45 degrees. If the side stick is released to neutral, the aircraft will return to and maintain wings level. The load alleviation function, or LAF, reduces wing structure loads in conditions of turbulence by rapidly deflecting the ailerons and spoilers 4 and 5 symmetrically upwards when the aircraft load factor differs by 0.3 G compared to aircraft demanded load. To assist with the high hydraulic demands required, dedicated hydraulic accumulators are installed near the associated controls. LAF is inhibited with slats or flaps extended below 200 knots or above VMO plus 10 knots. The load alleviation function operates in a degraded mode with associated failures. The LAF degraded message appears on the ECAM flight control page. With a total loss of the load alleviation function, LAF is displayed in the ANOP Systems column on the ECAM status page. With certain hydraulic system failures, control surface failures, or electronic flight control system, inertial reference, and/or air data computer failures, normal law characteristics and protections may be reduced or lost, and the aircraft will revert to alternate law. Therefore, it is imperative that the pilot fly the aircraft more attentively to avoid exceeding normal flight parameters. ECAM will advise the pilot whenever alternate law is active. The autopilot may or may not be available, depending on the nature of the failure. In pitch alternate law, as in normal law, the side stick still demands a G maneuver and auto trim is still available. Thus, pitch control in alternate law is very similar to normal law. However, the only protection available is the load factor limitation. With no pitch attitude protection, amber X's replace the double green pitch attitude limit bars on the PFD.
Because of the lack of high-speed protection, and to give the pilot more time to react to an overspeed condition, the high-speed envelope is further reduced to 320 knots Mach 0.77. The system introduces a nose-up demand to avoid excessive speed, but may be overridden by the pilot. This limitation is displayed on the PFD speed scale by the black and red VMO strip. In addition, there is an oral overspeed warning at VMO plus 4 or MMO plus 0.006. At the low end of the speed envelope, a nose-down pitch order is added, starting at 5 to 10 knots above the stall. That will gently push the nose over in order to keep the speed from decreasing further. If the pilot continues to pull the stick back, the aircraft will stall, since angle of attack and alpha floor protections are not available. An oral stall warning is generated at an appropriate margin above the stall. The PFD speed scale presentation changes in alternate law. VSW stall warning speed rather than alpha prot and alpha max is displayed at the top of the red and black band. It is also possible with a combination of failures to have alternate law without any kind of low speed or high speed protections. However, the load factor limitation is always available.
In alternate law lateral control, aileron spoiler deflection is always in direct proportion to side stick deflection. Along with the ailerons, only spoilers 4 and 5 are used in order to reduce the roll rate to a comfortable value. If spoiler 4 fails, spoiler 3 is available, and if the ailerons fail, all roll spoilers become active. Yaw damping is still available. However, in manual flight, turn coordination must be accomplished through pilot action on the rudder pedals. Bank angle protection is not provided. Amber X's replace the double green bars on the PFD.
Direct law becomes active when, for example, there is a triple inertial reference system failure, or both radio altimeters have failed and the landing gear is selected down. Also, in all cases where alternate law is the active law, as soon as the landing gear is lowered, direct law becomes active. The only exception to this activation of direct law is when alternate law has been activated from an abnormal attitude, which does not put the aircraft into direct law when the landing gear is lowered. Direct law in flight is extremely rare and usually momentary until the crew isolates the associated failed systems. In direct law, both pitch and lateral control is a direct side stick to control surface relationship.
There are no protections in direct law. However, oral overspeed and stall oral warnings are still available. The autopilot, yaw damping, and turn coordination are not available, therefore yaw must be controlled with rudder pedal input. In direct law, auto trim is lost and trim changes due to speed and configuration changes must be trimmed manually with the pitch trim wheel. The message Use Manual Pitch Trim is displayed in amber on the PFD as a reminder. Mechanical backup allows the pilot to control the aircraft in the event of a temporary complete loss of electrical power, complete loss of all 5 flight control computers, or complete loss of elevators, ailerons, and spoiler control. In pitch, this is done by manually moving the horizontal stabilizer by means of the pitch trim wheel. For lateral control, the pilot uses the rudder pedals. On the PFD, the message Manual Pitch Trim Only is displayed in red, except in the case of complete electrical loss. If the aircraft is thrown out of control due to, for example, mid-air collision or clear air turbulence, the abnormal attitude law allows the pilot to bring the aircraft back to within the normal flight envelope. The law becomes active when the aircraft exceeds any of the following limits: pitch attitude greater than 50 degrees nose up or 30 degrees nose down, bank angle greater than 125 degrees, angle of attack greater than 30 degrees or less than minus 10 degrees, airspeed greater than 440 knots or Mach number greater than 0.91, airspeed less than 60 knots or Mach number less than 0.1. The abnormal attitude law in pitch is similar to alternate law with no protections except load factor protection. Also, auto trim is inhibited when the aircraft is outside of its normal flight envelope. The lateral abnormal attitude law is full direct law with mechanical yaw control only. When the aircraft returns to level flight, pitch alternate law without protections and lateral direct law with yaw damping but no turn coordination is active. As well, auto trim again becomes active. The max flap slat speed for flaps 1 is 230 knots. For flaps 1 plus F, 215 knots. For flaps 2, 200 knots. For flaps 3, 185 knots. And for flaps full, 177 knots. Once a flap selection has been made, VFE, the max flap extension speed for that configuration, is represented by the red and black strip on the PFD. VFE next, the maximum speed at which the next greater flap selection can be made, is represented on the PFD speed scale by a pair of amber bars. Slow to less than this speed before making the next flap selection. The maximum altitude for slats, or slats and flaps extension, is 20,000 feet. For speed brake operation, there is no altitude limitation. However, for passenger comfort, it is not recommended to use speed brakes above 25,000 feet due to the higher than normal change in cabin pressurization that would occur. When performing the configuration safety check, confirm on the upper ECAM flap position indicator that flap position is in agreement with the flaps lever. Also check the position of the speed brake lever. If the flaps are not in the 0 position or the speed brake lever is not in the retract position, contact maintenance. Do not apply hydraulic power or move any flight control surface without first obtaining maintenance clearance. During the cockpit geographic check, confirm that all flight control computer switch lights are out on the left and right overhead panels. On the glare shield panel, ensure both captain's and first officer's side stick priority lights are out. The pitch trim wheels should be at 0. They were reset to 0 at the last landing. Caution: never attempt to move the trim wheel without hydraulic pressure. On the center pedestal, again ensure the speed brake lever is in the retract position and the flaps lever is in agreement with the ECAM flap position indicator. Normally the flaps will be in the 0 retracted position. The rudder trim rotary switch should be centered. Push the reset button to ensure the rudder trim is zeroed and confirm the position indicator is 0, plus or minus 0.8 degrees.
As part of the after-start recall scan flow, the captain selects the desired takeoff flap setting and arms the ground spoilers. Touch the flaps lever to select the takeoff flap, then touch the speed brake lever to arm the spoilers. The flap position is confirmed on the ECAM flap position indicator, and the message "Ground spoilers armed" appears in the memo section of the upper ECAM. If 2 minutes has elapsed since the second engine start, the takeoff memo appears, indicating spoilers armed. Taxiing out, clear of congested areas, the captain calls for the before takeoff check. The first officer then initiates the flight control check. Movement of the side stick automatically brings up the ECAM flight control page. The first officer checks each control surface on their respective control position indicator, pausing momentarily to confirm full travel. This check includes the 5-degree aileron droop with the flaps extended. He also confirms full side stick movement by observing the limit indices on the PFD. The sequence is side stick left, check, right, check, forward, check, aft, check. Note: when moving the side stick during the control check, do not move the side stick any faster than required for an aggressive flight maneuver to minimize component wear. This is particularly important during extremely cold conditions. Touch the side stick to perform the control check.
The first officer, after completing his portion of the flight control check, announces that he is ready for the rudder check, which is performed by the captain. The captain depresses the pedal disconnect button on the steering handwheel, then moves the rudder pedals in both directions. The first officer, while following through on his own rudder pedals, observes full rudder travel on the ECAM. Touch the pedal's disconnect button, then the left rudder pedal to start the rudder check.
The captain also checks for full and free movement of his own side stick by moving it either left or right, and either fore or aft, and confirms the side stick controller against the ECAM flight control page. This is a silent check.
The first officer sets the pitch trim from the load closeout data and observes this setting on the ECAM flight control page. In addition, rudder trim is confirmed to be at 0. During the takeoff roll, control deflection is in direct proportion to side stick movement. When takeoff power is applied, half travel forward side stick input should be applied to prevent the nose from pitching up. At 80 knots, gradually reduce this pressure to reach stick neutral at 100 knots. Routine use of lateral inputs to counter the effects of crosswind is not recommended. For crosswinds over 15 knots, small amounts of lateral inputs may be used to maintain wings level. Too much results in excess spoiler deployment, which has the effect of increasing the tendency of the aircraft to turn into wind, reducing lift and increasing drag. At VR, smoothly rotate the aircraft into the pitch command bar. At liftoff, as the aircraft transitions to flight mode, any lateral inputs used to counter the effects of strong crosswind must be relaxed to prevent the aircraft from rolling and to maintain wings level. This ensures a smooth transition to flight mode. Remember, in flight, lateral sidestick inputs demand roll rate. When the acceleration altitude is reached, the flap slaps are retracted. If takeoff was performed with flaps 2 or 3, select flaps 1 at F speed, the minimum speed for flap retraction. Then select the flaps up at S speed, the minimum speed at which the slats may be retracted. If takeoff was performed with flaps 1 plus F, they are selected up at S speed. Touch the flaps lever to select the flaps up. Once the flaps are up, the PNF announces "flaps up." The after takeoff check is then requested by the pilot flying as soon as practical, after the flaps are up. The PNF disarms the spoilers by pressing straight down on the speed brake lever. Disarm the spoilers, then touch the right arrow to continue. FMGC computed speeds default to flaps full. If a landing in Config 3 is desired, line select Config 3 on the MCDU Performance Approach page so that all FMGC computed speeds displayed are for the correct configuration. Line select Config 3. Also on the overhead GPWS panel, select Landing Flap 3 to prevent nuisance flap warnings close to the ground. GPWS Flap 3 is displayed on the ECAM memo section. Select Landing Flaps 3, then touch the right arrow to continue.
In a managed descent, if the aircraft becomes high on the profile, the message "more drag" is displayed on the PFD. Extend the speed brakes to the 1/2 position until the profile is regained.
On approach, the pilot flying calls for flap selections at the appropriate speeds. At green dot speed, select flap 1. In managed speed, the aircraft decelerates to S speed. Touch the flap lever to select flap 1, then touch the right arrow to continue.
Touch the flaps lever to select flaps 2. When flaps 2 is selected, the aircraft decelerates to F speed. At the appropriate time, the pilot flying calls gear down, landing check. The PNF arms the spoilers by pulling straight up on the speed brake lever and reads the landing check. Touch the speed brake lever to arm the spoilers, then touch the right arrow to continue. Touch the flaps lever to select flap 3 and decelerate towards V-app. If a flaps full landing was planned, select flaps full. At approximately 20 feet, Perform the flare maneuver by pulling back gently on the side stick to counteract the induced pitch down input. In a crosswind, the preferred technique is to use rudder to align the aircraft with the runway. If the input is gentle, very little if any lateral control is required. Remember, side stick input in flight demands roll rate. At touchdown, gently lower the nose. The ground spoilers will extend, if armed, when the aircraft touches down and the thrust levers are reduced to idle. The PNF confirms ground spoiler deployment on the ECAM wheel page, which was automatically displayed upon gear extension. If the ground spoilers do not extend automatically and the landing was made with flaps full, they cannot be extended manually. If the landing was made with flaps 3, it is possible to extend the flight spoilers only by moving the speed brake lever aft. The after-landing check calls for the flaps up. Slats flaps should be left in their landing position if the approach was made in icing conditions or following a landing on an ice, snow, or slush-contaminated runway. Touch the flaps lever, then touch the right arrow to continue. Disarm the ground spoilers by pressing straight down on the speed brake lever.
A fault in a single flight control computer requires that it be switched off, then on again, to attempt a reset. The other computer assumes the functions of the failed computer, except for a sect failure, where the associated spoilers will be lost. Caution, do not reset at ELAC if uncommanded maneuvers occurred during the flight. Touch the right arrow to continue.
The failure of both ELACs or FACs, or all 3 SECs, again requires that they all be reset, and if unsuccessful, the aircraft will be in alternate law with associated protections lost. Touch the right arrow to continue. The flaps are currently selected to and indicating Config 1 in flight. Touch the flaps lever to select Config 2. Recall that due to flaps or slats asymmetry, runaway, or uncommanded movement, the wingtip brakes are activated and the flaps and/or slats are locked in their current position. The wingtip brakes can only be reset on the ground. In this example, the flaps have locked between positions 1 and 2. The flaps locked caution is generated, along with the master caution and single chime. ECAM advises that the wingtip brakes are on and displays the maximum flap extension speed for the current flaps lever position. This speed is also represented by the red and black max speed strip on the PFD speed scale. Clear flight controls by pressing the Clear button on the ECAM control panel. The status page indicates that flap 3 is to be used for landing. The approach speed additive is added to the VLS speed as displayed on the MCDU approach page and is manually entered by typing it into the scratch pad, then line selecting it into the VApp field. The landing distance must be increased due to the higher approach speed and loss of aerodynamic braking from the flaps. If a diversion was necessary, consider increased fuel consumption to the diversion airport. Refer to FCOM 3.02.10 operating techniques, which gives landing, go-around, and diversion procedures and fuel consumption guidelines. Clear status by pressing the Clear button on the ECAM control panel. With a jammed stabilizer, the ECAM procedure recommends checking the manual pitch trim and if it is available, trim the aircraft to maintain neutral elevator as indicated on the flight control page. Alternate law becomes active and the autopilot is not available. However, on the A320, control is much easier than on a conventional aircraft because in alternate pitch law, the flight control computers will deflect the elevators in order to maintain 1G with the side stick neutral. Clear flight controls by pressing the clear button on the ECAM control panel. Flaps 3 is used for landing, and if manual pitch trim is not available, landing gear extension is delayed until the flaps are in config 3 and the speed is reduced back to VAP. This is because once the landing gear is down, direct law becomes active, and although the previous elevator position is maintained, any further speed and configuration changes would require constant side stick pressure. Control forces, however, will be light due to the lack of an artificial feel system. The approach speed must be modified to VREF plus 10 on the MCDU approach page, and a landing distance factor must be applied to the landing distance. Whenever this factor is not displayed on ECAM, it can be found in FCOM 3.02.80 Miscellaneous Procedures or in the QRH. In op systems are listed on the right-hand side of the status page. Attitude, overspeed, and alpha limit protections are not available in alternate law. Clear status by pressing the clear button on the ECAM control panel. If the pitch trim wheel is jammed, the ELACs may not detect the failure. There will be no ECAM warning, and normal law remains active. The only indication of a problem may be that on the ECAM flight control page, the elevators remain deflected. The procedure can be found in FCOM 3, Abnormal and Emergency Procedures, Flight Controls. Disconnect the autopilot, then check the manual pitch trim operation, and if available, trim to maintain the elevator at the 0 position. If not available, use flap 3 for landing. A side stick fault is generated to warn the crew of a faulty side stick. It is triggered when a pitch or roll transducer has failed. Touch the right arrow to continue. With the loss of both elevators, only manual pitch trim is available for pitch control. As well as the ECAM warning, the message Manual Pitch Trim Only is displayed on the PFDs. Do not use the speed brakes because of the induced pitch changes, which may be difficult to control with manual pitch trim only. Clear flight controls by pressing the clear button on the ECAM control panel. The status page outlines the approach procedures and reminds the pilot that pitch control is mechanical backup and roll control is direct law. Clear status by pressing the clear button on the ECAM control panel.